Okay, so let us wait for a few minutes, then we can start if anybody joins. Okay, so let us wait for few minutes more, 3 minutes, then we can start. Am I audible?
Yes.
Okay, let me share my screen. Screen is visible, right?
Yes.
So today is our last class, and today we'll discuss the statistics part. Okay. So let me connect. This port. This part is very important, basically. Okay, Be because this is uh, important because this is the main statistics part. Uh, in statistical mechanics or statistical thermodynamics, everything you have done, that's okay. But if you want to uh, understand the statistics, then this part is quite interesting. I think you have probably heard about this topic, the random variable.
Yes.
So this is very, very interesting and very, very important as well. So this part was also discussed in class, but in earlier class. Later it was not discussed. So I thought discuss this because this will give you a very good insight. Why you calculate this variance, mean, or standard deviation? What is the physical significance of these things? These things are very important. Yeah, connect. Let me connect it. It's not connecting. So today we will discuss these things. Okay, am I audible, right?
Yes.
But the sound is not coming in my headphone. It is just it's connected, it's showing connected, but the sound is not coming. It's okay, but otherwise in recording the sound will break. In live class it will not matter. So what do you mean by random variable? Why it is called random variable?
It can take any random value.
Random value, and there is no bias basically. Okay, that's why it is called random variable. So let us take an example. It's better to understand by taking a simple example. Let two fair dice are tossed. Both are fair dice, and sum of the scores of that two dice, sum of the scores is S. Let's say S. So, what will be the values of S?
1,
It can be
6, 1, 1, 1, 2, 1, 3.
no. I'm saying S. S is the sum of the
Start from 2,
2. 2 to
12.
12. So this is the possible values of S. Okay. This is called sample space. Clear? These definitions are very
Yes.
important. This terminology will be used several times in statistical mechanics. Later you will see the sample space, size of sample space. This is very important. Okay. So now in this sample space, you can set different type of operations that I will discuss briefly. Just let us discuss something. An example. Let's say, so there are two dice, right? If you remember, there are, so how many results are there? This is S, but number of microstate. If I ask number of microstates, then what will be the microstates? Can you guess it?
The 1 1 1 2 dash thing.
Exactly. So the microstates are 1 1, 1 2, 1 3 to 1 6, something like that. So total number of microstates will be 6 into 6, 36 microstates will be there. Okay. And each states are equally probable. Each of the microstates are equally probable. There is
Yes.
no bias, fair coin it is, fair dice it is. So obviously, the probability of each microstate is 1 by 36. This is my microstate. And what was the macrostate? This is the macrostate S. Here you will understand the meaning of the exact statistical meaning of macrostate and microstate. You have studied in terms of our statistical thermodynamics. That's okay. The same thing. Same thing. Let's say if I say the macrostate S equals to 5, then what will be the microstate under it? It may be 1 4, it may be 2 3, it may be 4 1. Anything else? Yes, it may
3 2.
be 3 2. That's it. So 4 microstates are there. So that's why it's called macrostate. Macrostate is 5 and microstate is 4. These are microstates. Same definition was there. Folder file relation. See, these are file and this is the folder, right? These are the kind of files and this is the folder. Under this folder, there are 4 files. So now, if I say, what is the probability of PS? Or you can write it like probability of S equal S, something like that. You can write it like that. This as well. Same thing. Okay. Let's say what will be P5 because I have written the 5.
4 out of 36.
Exactly. So it is 4 by 36. Or you can write it 1 by 9. So this is P5. So eventually you can calculate for all. It is not difficult. Correct? But you can write it. One thing you can write it definitely. If you sum it, S equals to 2 to 12, then it will be 1. Correct? It should be 1
Yes.
because total probability is 1. Now, if I ask, it's okay, but for which S this is maximum? for which s this probability will be maximum.
2 are same.
Hmm? P5 is 1 by 9, it is P5. So if you calculate all, you can calculate, check it. You have to just write S equal microstate, and you have to identify the number of microstate under it, and then you can easily calculate the probability. That's the case. So just I am doing the S equals to 7. This is the maximum. So you will see the number of microstates are 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. So P7 will be 6 by 36, it is 1 by 6. So this is the maximum probability. Okay, I'm just giving you example. And if I want to write the formula, general formula PS or PS, this is 1 by 36 S minus 1 when S is this, and it is 1 by 36 13 minus S when S is this. So this is the formula of this probability. You can check, and this will be the formula definitely. So why I am discussing this? Because you see, this S is creating a distribution, right? Okay. So if you plot, let's say S and probability of S. So you will see there will be a distribution, and it maximize when S equal to 7. So this is a distribution, correct? Is it clear how it forms a distribution?
Yes.
Okay. Now, so that's why uh, this distribution important. Now there are several kind of distribution called our binomial distribution, Poisson distribution, geometry distribution. These are well known and well defined distributions. So we will learn, we will discuss that these things. These distributions are how these distributions are made. So let's say this example is clear, right? Now let's say one free coin is taken for toss, and probability of head is p, small p. So what can be the values of p? P should be within 0 and 1. And so what will be the ends probability of tail? Q. So what will be
1
Q?
minus p.
1 minus p. Perfect. 1 minus p. Now this, now listen very carefully. This is very crucial part. Here you will understand what is a random variable. Now, n times you have tossed. Correct? N times you have tossed. One single coin you have tossed n times. So what will be your sample space?
2 to the power n.
No, I have not sample space, I have said, not the sample size. Sample space, that means the elements, the set. N times you have tossed.
All are head, one tail, and all head. That's
Anything can be, right? So
yes.
just you have tossed N times. So maybe you have here I'm writing sample space of what? Having head. It is possible that you have obtained zero times head. All time you have obtained tail. So maybe it may be zero, it may be one, it may be two, up to n.
N.
All heads. This is possible. So this is a sample space of P. Correct? Because having head is okay. So this is number of heads, right? Let's say this is n. Number of heads is n. This n is random variable. Just see, because you don't know. It's totally random. Let's say you have tossed 10 times. You don't know how many times you will obtain the head. Correct? So it should be a random variable. It is a random variable. If it is a biased coin, then you know that. Okay. So is it
Yes.
clear why it is called random variable? This is the number of heads.
It is not biased. And it can take
It
any
is
value.
not biased. You have tossed capital N times. You don't know how many times it will take head, it will take tail. So this number of heads N, this is totally random variable. Okay. But you know, N should be belongs to this value of N. That's why this is the sample space. This is called sample space because N should have take value between this. N can be 0, can be 1, 2, up to N. Now, what is the probability of N? This is probability. Can you say it? What is the probability of N?
For binomial distribution,
Yes, it is the binomial distribution.
NCR, P to the power R, Q to the power N minus R.
So it is NCN because you are finding number of heads, right?
Yes, P to the power N,
N
Q
is
to
the
the power
number of
capital
heads.
N minus all that.
Exactly. P is the probability of having head and Q is the probability of not having head,
Having tail.
having tail. So this is the distribution. So this is the binomial distribution. So basically, this random variable, so for every random variable, there is a distribution. Just listen, it is a random variable, but random variable is random, but the probability will follow some distribution. That is the binomial distribution here as an example. Okay, it may be different distribution. This is coin toss, that's why it is a binomial distribution. You will see for later cases there may be geometric distribution, that may be Poisson distribution, that may be scalar distribution. There are negative binomial distribution. There are lots of different types of distributions are there. Okay, so now you can check. This should be 1
Yes,
and sum should be 0 to capital N. This is the N should be run from the sample space, not 0 to capital N. That's why. So how you can solve it? Q is basically 1 minus P
1 minus P.
n minus n. So this is the direct formula of P plus Q to the power n. Binomial formula. That's why it is called binomial distribution.
Yes.
And P plus Q was 1. So it is 1. Clear? Okay. Now let me make it start. So if there is a random variable, then there must be a what? Probability
Probably.
distribution. I need space. Function, right? This is the probability distribution function or probability distribution, whatever it is. There must be. This is called PDF. So if there is a random variable n, then there is must be a PDF P of n. Is it clear?
Yes.
Okay. Why I'm saying because later you will be confused. There are different type of distribution function. That's why I'm saying. I'm specifying it. Okay. Now, why it is important? Can you say why this probability distribution function is important? You know these things we have discussed already, not in
To
this
know the
context.
maximum.
Uh,
To know the maximum.
mhm. No, there is a direct implications of this probability distribution function. Where? Why this is important? Let's say you want to calculate the average of n. What will be average of n?
Sum over n into probability of n.
Exactly. That's why. That's why you have to know the probability distribution of n. Then only you can calculate the mean. So this is the mean. So this is called mean or average, whatever you want to say. Okay. So do you want to calculate it?
Yes.
What will be the n? For binomial distribution, what will be the n? I mean, sorry, not n, n average, I'm saying. Okay, we'll calculate it, but let me first define things. Okay, this is n. So in general, this is not general. In general, you can write it like this. Correct? Okay. This is not the mean. Mean, if it is k equal to 1, then it is mean. Okay, now you can calculate. So n average was this. So just put Pn was nPn p to the power n q to the power n minus n. So what will be this value? Can you calculate it?
I am
Now,
trying.
now things will be quite complicated, but just listen it carefully. It is very interesting. It's not difficult. Just you have to listen it. Okay. So this is not possible to calculate always. Means this is not it's difficult to calculate this sum. It is not direct binomial, right? Is it?
No.
Is it, let me write it. You can write it like uh, p to the power n, and this is 1 minus this. So then what you want, you don't know, no, right? So how you can calculate? I'm saying if you want to calculate this, this value, not only the average, nk average, then how you can calculate? Is it not? This is not easy. It will be nk, so it will be k. So calculating this sum is not easy. So how you can bypass this problem? For that, you need a generating function. Okay, generating function. What is that? That is denoted as fz. Clear? Hello? Okay. So how it is defined? Fz is defined, this is the sign, defined like sum over n, 0 to n, z to the power n, probability of n. Okay, this is the definition of generating function. This is general, not this coin tossing case, not for binomial distribution. This is overall general. Later you
For
will,
any distribution.
for any distribution, this is the general definition of generating function. This is the generating function. So why it is important? Why it is important? Why generating function is so important? Because f dash z at uh, z equals to 1, it will give you an average. Okay. Or in general, you can say df dz to the power k fz at z equals to 1. This will give you nk average. Now, that's why it is important. You can calculate directly the average or kth average. Kth mean. Do you want to check it? Let us
Yes.
do. Yes, for this binomial distribution, you can easily check. For binomial distribution, what will be fz? That will be n, z to the power n, and pn. Pn, you know, pn is n, pn, p to the power n, q to the power n minus n. So what will be f dash z? F dash z will be, you have to take the derivative with respect to z, right?
Yes.
So you see, you can do it in general because z is only here, not in p. So direct you can do it. So it will be z to the
N
power
into
n.
z to the power n minus 1.
So it is n into z to the power n minus 1 pn, correct? So put z equals to 1, or you can write it like this. It will be n 1 to the power n minus 1. What will be the 1?
1.
So it is okay.
Yes.
So you see how many times you will make the differentiation with respect to z, the n power will increase, right?
Yes. So k
That's the
derivative is
case. So it will be
nk,
e to the
right?
power k. So this is a brilliant mind actually. If you just make derivative with this, let's say k times, then so it will be directly, and write it n, then n minus 1
N minus 2 to 1 n factorial.
something and so on, right? Up to uh it's k, so n minus k plus 1 up to, I think, if you do it, it will be that. Okay, when it is first derivative, it was n, means n minus 0, correct? 2, ha, it's correct. So this, and after
Yes.
that it is z to the power something. When you put z equals to 1, that part will vanish. So it will be p to the power pn. So this you will have. So this is not n square or nk something. So yes, so this will give you nk, but not directly. That will calculate. Just now we'll calculate. So that's why generating function is important. So now let us check how we can calculate the n average. Till now we don't know n average. Till now we don't know. We only know this is just f dash z at z equals to 1. Correct? This is clear. So now we'll calculate this. This is okay.
Yes.
What you can write?
U s 1 minus p.
So when it is p to the power n, q to the power n minus 1, or you can write it as 1 minus p to the power this, then it was p plus q. Correct? So it should be pz plus q. Nothing is there.
Yes.
There is pz plus q to the power n. It is direct binomial now. So pz plus q to the power n, you know. Now you know what you have to do. You have to just calculate f dash z. What will be f dash z? You have to take the derivative with respect to z.
N
So
into
before
pz plus q whole to the power minus 1.
say it.
N into pz plus q to the power n minus
So
1
you have,
into p.
let us do it. Okay, just do, it is ddz of pz plus q to the power n. Correct. So let this is a something u. So ddu of u to the power n and du dz. This is p, only p,
Yes.
and u is pz
Pz plus q to the power n.
n. So what will be at z equals to 1, np p plus q to the power n, and p
It's
plus q
1.
is
So
1.
np
So it is np. And you know that f dash z was directly n average.
n average.
So this n average is np. So by using this generating function, you can calculate directly this average. So now, can you calculate the variance of n? You know what you have to do. What do you have to do?
N average minus N average square.
Do it. How you can calculate that? You have to take the second derivative, right?
Yes.
It is not directly, I have said, it is not directly the NK average, but it will be up related to NK average. So variance is related to N square average. So you have to definitely consider second derivative. Okay. Because if you calculate N square average, then you know N average. So you can then calculate the variance. So for calculating variance, you have to first calculate the N square average. So that's why you have to take the second derivative. So what will be second derivative? Second derivative will be derivative of this, correct?
Yes.
So NP will be as it is. Again, it will be the just dtz of tz plus q to the power n. So what will be this?
1p will come out and n into n to the n minus 1.
So it will be n minus 1 times p, right?
Yes.
And then this part will be as it is. No,
N minus 1, n minus 2.
it will be
In the
p
first term,
plus.
it will be n
No, no, no,
minus
it's
1.
correct. It's correct. It is just n minus. Okay, just see the derivative.
In the first one, it will be n minus 1.
It is n minus 1. NP is from here.
After the first derivative, the power should reduce by 1.
Oh, this is n minus 1 you are saying, right?
Yes.
Hmm.
So this will be n minus 2.
This will be n minus 2. Correct. Okay. So this will be just you have to put. So it is n minus 1 p square p plus q to the power n minus 2 and p plus q is 1. So it is n minus 1 p square. Okay.
Yes.
So what is this? What is this you can say? This is average of n minus 1, n minus 2 up to n minus k
N
plus
minus
1.
k plus 1.
Nothing. So you have taken the second derivative. So it is the average of n into n minus 1. Perfect.
Yes.
And what is this? If you just break it, it is n square minus n average. So n square average minus n
Minus
average.
n average.
So now you know n square average. I said it will leads you to n square average, but you have to calculate it. This is p square. N average you know. So n average was np. Np plus n into n minus 1 p square. So take common np. So it is 1 plus n minus 1 p,
N
right?
minus 1 into p.
Or
1 plus np
or
minus
better
p.
we can write it like n square p square minus np square. Okay, this is n square average. This is n square average. So what will be the variance of n? This one.
Yes.
and this is,
N square P square.
this will cancel. So this is NP minus NP square. Take NP
NP
common.
common 1 minus P. NP cube.
So this is your variance. So you see, by using generating function, you can calculate the variance n to the power k. Anything you can calculate. That's why this generating function is very much useful. Okay.
Yes.
So this is what this is called kth mean. Okay. Clear?
Yes.
And how you can calculate it? For calculating it, you need a generating function fz, which is
Its kth
defined by
derivative.
n, sorry, z to the power n, and this. And when you uh, make it kth time derivative and z equals to 1, what you will get? You will get n minus 1, n minus 2, up to n minus k plus 1.
K plus 1.
And from here, you can calculate this. This is a procedure to calculate the kth mean. Okay. By the way, what does it call? This is called kth factorial moment. Okay. And this is also called kth moment.
NK average is kth moment.
Huh. This is also kth moment. This is kth factorial moment. This is kth moment. So from generating function, you can calculate kth factorial moment, and then from kth factorial moment, if you subtract the other parts, here see you have to subtract the mean and something, then you can calculate the kth moment eventually. So variance is not the second factorial moment, not the second moment. You see, variance is not that. Nothing. Variance is something different. Okay. So is it clear?
Yes.
Okay. So I can give you another example. Before that, I have to clear these things 1 minute. Now you can calculate this is for any other distribution as well. The procedure is same. For any distribution, n is random variable. Just Pn will change. You have to just put Pn here. You have to calculate the generating function. Then you have to take the derivative and you will have the kth factorial moment and you can calculate the kth moment from there. This is the standard procedure. Okay. So now what we can do, it was written 1 minute. Let me check. Hmm. Lots of things are there, but we can't do everything. Okay, okay, okay. I'm searching something different. It's okay. Yeah. Okay. Now, so what is the variance? Variance is not the kth factorial moments. It is not the our eighth moment. So what is the variance? Can you guess it? For variance only, not for higher order, higher things. What does it call?
Which thing?
Variance. Variance is not your kth factorial moment because, or second, I'm saying this is your second factorial moment, right?
Yes.
And this is your
Second moment.
second moment. Both are not variance. What is variance? Variance is,
N square minus N inherent.
or you can write it, there is another definition of a variance, that is n minus this, then you have
Whole
to take the
square.
average, whole square, and then you have to take the average, correct? This is the variance.
Yes.
So what does it call? It is not the factorial moment, it is not the our second moment. So what is this? That I'm saying. That's why here you have to introduce one more terminology, that is called central moment. That's why I'm saying you have to just focus it. It's not difficult. You have to just distinguish things. Otherwise, it will be just messed up. Okay. Otherwise, things are not difficult. What is central moment? First central moment. If I say first central moment, first central moment, from the name you can see central means it is the moment or deviation from the center. Center means mean, right? So it is just deviation from the mean. That's it. This is the central moment. Okay. See, just grab it, then we will proceed. It is the central moment.
First, second, anything.
I will come. This is first. So in general, there is a K. So this is Kth central moment. So what is first central moment? This is
Zero.
0. So first central moment is always 0. These things I have mentioned before. What is second central moment?
Variance.
This is the variance. This is the variance. Okay. What is third central moment? Just it will be 3. This is called skewness. There are different names. So most important things is our central moments. Okay, it is more useful than moments. So NK average is your moment, kth moment, and this is your kth central moment. Is it clear?
Yes.
And how you can calculate that? Kth central moment from the kth factorial moment as well. So you know the kth factorial moment. So kth factorial moment, so you can calculate kth moment. And if you know kth moment and previous moments as well, then from there you can calculate kth central moment. We have done the same thing. Just see, we have just calculated the second. This is the second factorial moment. This is second factorial moment, right? From there, you have calculated the second moment and then second central moment. Okay, this example we have already done. But is there any other method to calculate this central moment easily? That is important. So you see, this procedure is difficult to calculate the central moment, right? First, you have to calculate the
Yes.
case. First, you have to define the generating function. After defining generating function, you have to calculate first kth factorial moment. That will give you kth factorial moment. Then from that kth factorial moment, you have to calculate kth moment, and then you will have kth central moment. So bypassing these things, how you can directly calculate the kth central moment. For that, you need a different function. So now we will introduce another function. This is m. This function is called m, function of u. U is a variable. Let's say if z was there, right? Generating function was denoted by if z, correct? Z was the
Yes.
variable. Z was not random variable. Z was another variable was introduced there, here, correct? Here, similarly, we will define another function that is mu. How it is defined? Mu is average of e to the power un. N is a random variable. Okay. So how we can write it?
What is U?
U is another variable like here z. Z was variable na introduced here. Z to the power n like that. After you have to do derivative with respect to z here everything. Z is not the random variable. Z is another variable that was introduced to calculate these moments actually. You see there after you will put z equal to 1, so there will be no role of z ultimately. Correct? Just z was introduced to calculate these things. Okay. Is it clear or just grab it?
Yes.
I'll go slow because things will be otherwise complicated.
Okay.
Okay. So you can simplify it. So it is sum over n e to the power un pn. Something average means that into probability. PDF.
Yes.
Is it clear?
Yes.
So what is this actually? This is just this. See, generating function fz was z to the power n pn, right?
Yes.
So it is just f of e to the power u. Is it clear?
Yes.
Okay. So this is called, what does it call? This is called moment generating function. Okay. And this was the generating function. So let me summarize, otherwise it will be complicated. So generating function, that is your fz, that is your fz, which was defined as sum over n z to the power n p of n, gives you kth factorial moment, right? And from here you can calculate kth moment, or you can later calculate kth central moment. This was technique, but it directly gives you kth factorial moment. You see? Okay.
Yes.
So now from here we will define another thing, that is moment generating function. What is that? That is nothing but generating function, not of generating function of e to the power. Instead of z, it will use e to the power z, something like that. So it is just related. Generating function gives you the moment generating function. So it is written by m of u, and it is e to the power un pn. So it is eventually this. It can be also written as this, right? Okay.
Yes.
What will it give? So how you obtain this k factorial moment? You have to just derivative things, right?
Yes.
Similarly here, you have to make derivative, but here u is the variable, not 1, it is 0. At 0, you will have the direct kth moment, this part, directly kth moment. Okay, so from there you can calculate the kth central moment. So one step was reduced. So you can check it. Just like we have checked the generating function, for here it also you can check it whether the first derivative will give you the first moment or second derivative will give you the second moment or not. Okay, let us check. Let's say we have to calculate n square. We have already calculated n square for our binomial distribution using the generating function, right? And what was that?
Yes.
It was this np plus n square p square minus np square. So np, this. We'll check whether we'll have the same thing or not using the moment generating function. So what is moment generating function here? It is n e to the power un and then p of n. un, and here it is your uh, n p to the power n q to the power n minus n. Okay, so just let me check. Huh. So from here you can calculate it. Let me calculate. And it is not done for it's not done for the binomial distribution, okay, but we can do. Obviously, we can do. Just what is this? It will be
Q into the same.
this thing.
Yes,
Now at u equals to 0.
it will be 0.
No,
After doing the derivative, I am getting
okay. So first derivative it give the first moment. Second time, second derivative. This will give you first. It will be n
n
again
into n
n.
minus 1. Yes, this is.
So you can see directly after doing kth derivative, you will have this. What was the problem in previous case? It was not e to the power. It was z to the power n. So that's why after doing derivative, it was reducing. N was after that secondary, it was n minus 1, then n minus 2. These things was appearing, right? But just introducing e to the power n or un, it is just the n will repeat. So you will directly have the kth moment. Okay, so it is working, right?
Yes,
Great. Okay, so things are okay. The last thing that is you see till now we have not calculated direct any formula for kth central moment. This is missing. Basically, we need the kth central moment, correct? That is still not known.
yes, but not directly.
Not directly. Ha, you can calculate the kth moment directly by moment generating function. Okay, the short form are also important. This is called GF. This is called MGF, or this is also called characteristic function. Okay, this is also important. This M is also called, there is another name of it. This is called spelling, I don't know. Stick function. Okay, GF and MGF. Now the most important thing, that is, now we will define another generating function that is called cumulant generating function. That is called CGF. Okay, is it okay? How it is defined? and it is written as K, not K, it is kappa, something like this. In this way it is written. So, so generating function gives you K factorial moment, right?
Yes.
MGF gives you
Kth
direct
moment.
moment, Kth moment. So this cumulant generating function gives you cumulants, not the central moments. Central moments nahi deta ye. This gives you kth cumulants. But what is the cumulants? That is important. That we till don't discuss. We have not discussed. So now we'll define. So this cumulant generating function is defined like this. Ku is nothing but just ln of mu. It's as simple as that. Mu is your moment generating function. It is just logarithm, natural log of moment generating function. CGF is just natural log of moment generating function. Okay? Or moment generating function is e to the power CGF. Clear? So here also you can write it. Okay?
Yes.
So mu you know. This is your mu. E to the power
Average of e to the
mu.
power u.
So mu, we know what is the form of mu. So what will be your CGF? This. This is your CGF. Okay? Okay?
Yes.
Now, similarly, if you differentiate kth times at u equals to 0, then you will have kth cumulants. As simple as that. If you differentiate kth time the generating function, you will have kth factorial moment. If you differentiate kth times your MGF, you will have the kth moment. If you differentiate kth time your CGF, you will have the kth cumulants. That's it. Okay.
Yes.
Okay. Mhm. Now, if I say, let us calculate what is your first cumulant. You don't know what is cumulant till now. You know what is your moment, what is your central moment, what is your k factorial moment, but you don't know what is your cumulant. That we'll see what is our cumulant. So let's say first cumulant. What is our first cumulant? So it will be D. This gives you our first cumulant, right?
Yes.
What is Ku? ln of
ln of mu.
mu. So this is essentially, or in general we can do, later we will put u equal to 0. So it is 1 by mu times correct.
Yes.
And what is this?
N average.
First, this is
First, no, the second one.
this you have already defined. If you remember, these things already
First
defined, like
moment.
first moment.
Moment.
So it is n average. When it is u equals to 0. Otherwise it is not. If it is at u equal to 0, it is n average. So you have to write it as n average by m0. Then it is correct. And what is m0?
Sum over Pn.
And what is that?
1.
So what is our first cumulant?
First moment.
First moment. So our first cumulant equals to our first moment equals to our first factorial moment. K factorial moment was n minus k plus 1. If you remember, what was our k
Yes.
factorial moments? N minus 1 up to n minus k
N
plus
minus k
1.
plus 1.
So first will be n into
ஒன்றும் பிரச்சனை இல்லை சொல்றோம் ப்ரோ ஏன் கொஞ்சம் கவலைப்படுற அவன் அவ்வளவுதான் இப்ப வேலை ஒழுங்கா பண்ண மாட்டான் இல்லடா சூசைட் பண்றாங்க ஏன்டா எத்தனை அவருக்கு சம்பளத்தை 3 மாசம் ஏற்றணும் அப்படின்னு சொல்லிட்டு மறுபடியும் எங்களை மாதிரி மாத்திரடா நிறைய பேர் அப்பதான் பண்றாங்க இவனுக்கு அப்டேட் பண்ணீங்க
is disconnected. Wait for a few. These things are yes. Okay. Am I audible now? It is visible, right?
Yes.
Okay. So for first factorial moment, it is n into, it will be goes up to n, right? So it is just n average. Correct?
Yes.
That's why from our generating function we will have already the factorial moment, first factorial moment, but that is direct gives us the n average because this is the same thing. First factorial moment and n average, this all are the n average mean. So these we can have from CGF, these from MGF, and these from GF. Same thing. Correct? What is our
For the
second?
first one.
You see, same thing, na?
Yes, for the first
First,
one.
first one. First factorial moment, and first cumulants all are the same. Second cumulant. So how we'll calculate it? D2 at equals to 0. So it is d du of 1 by mu, and it was this, right?
DMUD.
Dmu du. So here you have to break it. Obviously at u equals to 0. So first 1 by mu is constant. Is d2 mu by du plus, and it is okay. Mu is there.
Minus 1 by mu square.
Minus 1 by uh, mu square, that is okay, and
DMUD.
also dmu by du, correct?
Yes.
Yes, and both are at u equals to 0. Okay, u equals to 0, this will disappear definitely. It is just probability PDF, sum over PDF, that is 1 m0, correct? So it will be just these things. This is direct your n square average.
Yes.
And what is that?
Yes. N average square.
What is this?
Variance.
Or
Second central moment.
so second cumulant is your nothing but second central moment. That means your variance. Okay, that's why this CGF is important. Okay,
Yes.
third one, you just do it. Try third cumulant. What does the third cumulant signifies? So just let me summarize it. So here, so CGF gives you the, after double derivative, you will have the second cumulant, which is nothing but this. Clear? Now what the third cumulant signifies? Third cumulant. Just calculate and see what does it.
Very large expression.
Do we do?
N cube average plus 2 n square average minus n square average into n average.
Repeat it.
N cube average plus 2 n square average minus n square average n average.
I'm doing. Just check it. Okay.
Okay.
So now we'll calculate the third cumulant. So it is just third time derivative of our CGF. That equals to 0 definitely. So it is just derivative of our previous result. This. So derivative of 1 by mu and d2 mu du, right? Minus 1 by mu square dmu du square. So if you derivative it again, so from the first term it will be mu, let's say there, cube plus this again give you this second time derivative, it's square, and it will be another dmu du minus minus and this minus minus will be plus and another d. Same thing.
Yes.
Okay. Now we will just put for all case equal to 0.
Mu
So
equal to 1.
so it is just n cube average, right?
Yes.
This is n
N square
square
average n
average,
average.
n average. Next one,
N square average.
n square average. And the last one, 2 of
N average square.
n average square. Now it is something is missing. Okay, okay, okay. This was square, right? Here it is a square. This is square. This is not there is a square. So basically three terms are there. DMU, DMU. Okay, so this is not like this. Sorry. You see, this is the square. You have to derivative of that square term. So it will gives
Yes.
you 2 dmu du, and again you will have the dmu du, right? So
Yes.
this you will have. And last part was correct. Q and again dmu du. Now put u equal to 0, then it is n cube
I am
average.
getting the last plus as positive.
Positive, positive, and it is plus, no, minus n square average, n average minus 2 of
N square average
square average, no, n average
plus
square,
N average N square average.
and this is n average cube. Hmm. Okay, okay, okay. This is 2 of that. So just let me check one if is correct. Okay, no, this is not match. The this is actually 1 by mu, then it is 1 by mu square.
DMU DU
It is, there is a 2, right? Here it is a 2. So it is dmu du and d2mu du. This is, check it.
yes.
Why? Because square, right? So you have to just derivative. Uh, let's say this part is, entire part is something, let's say a. So it is a square. So then it will be 2 of that. So 2 will be there,
2A
obviously.
DA DX.
2 will be there. And that after that, 2 derivative will be there. Now that's why it is 2. That's the thing. Okay, so it is, you can break it and you will see it. This. So it is,
The second term is positive.
no, there is a negative.
Yes, there is a negative.
So what is this? Break it, you will see. N cube minus 3n n square plus 3 n square n average minus
N average Q.
n average cube, right? So it is n cube average plus 3 cube plus 3 n square average n minus, not 3.
Only at Q average.
So it is n cube average plus 3 n square minus
N average Q. 4 N average Q.
square. Oh, I have written the formula wrong. It is square. It is this a minus b whole cube formula.
Yes.
So it is matching, right?
Yes.
So it is third central moment. So third cumulant is your,
Third central moment.
you can try your fourth one. What will be that?
It will be very, very long.
It will be very, very long. Yes. So, fourth cumulant, let me see. Yeah, this is the note. You will have the total list there. Fourth cumulant, you can try it. What will be?
For central moment.
Plus 3 second moment square. Okay. So it's
This
not,
time will be there.
it's not direct. Then so this can be called central moment generating function. Right? This is cumulants and the central moments are not the same. This is
I
same
thought
for,
it was same.
I also thought when I was studying, this is same for second and third only. Okay. This is not same for all cases. Just like write the fifth cumulants or K5. It is written like K5. K5 is your uh, N5 plus 10 into N3 N2. K6 is,
In 6, 7.
no, you can predict it actually.
It does not have any general formula.
No, wait, like that. This is available in Google. I am writing from Google only. But it's important for only up to second and third. Later part are not important. That is the reason. Okay. So this is your cumulants. So cumulant generating function, cumulant generating function is actually written as K of u, and the cumulants are written Kr. This is Rth cumulant. So how it is related? It's okay. This is the case. Is it okay?
Yes.
Now, why these cumulants are so important now? You see, this is not direct something like from random variable, you can think like uh, moments, central moments, these things are okay. But these cumulants are not some feasible thing. You will not think purely about this kind of abstract thing like these things you will not be thinking. So what is the physical significance of this cumulant? So why these cumulants are most important thing for this random variable? For that there is a reason that we will discuss. So कहाँ जाता है पता नहीं. What minute? Yes. This is your n random variable, right? If
Yes.
if random variable is changed from n to m, let's say n to m, or more specifically, it is let's say being changed from n to some constant c of n. C is a constant, okay, multiplied by a constant thing. So surely your moments, your factorial moments, central moments, all will not be the same. So it is a new variable, new random variable now, m, which is c times n.
All will be multiplied by c.
No, that is the problem. Only cumulants will follow that rule. Means rth, for rth, what I'm saying. This is for n, m, and this is for. Let me do it specifically. For n case, let's say the rth cumulants are written by kr, and there must be a symbol for n. So let's say n. N is not, this is not power. This is also rth cumulants, but for variable m, it will be c to the power r times this. This is the characteristic of these cumulants. Okay. Let's say
Yes.
other random variable is there. Let's say L. L is another random variable L. So, and this cumulants is this. So, let me define new random variable O, which is n plus L. New random variable. Then you can write kr of O is equals to kr of n plus kr of L. Additive. How you add the, obviously this random variable should be independent random variable, not should not be dependent each other. Independent. This, that's why these cumulants are so important. And, and we have already shown that for our second and third cumulant, that is directly our radius and skewness, means the central moments. So that's why cumulant CGF is very, very important. Okay,
Yes.
great. And last thing I will mention, and this thing, it is sufficient, more than sufficient. These things are not discussed in general courses. That's why I thought to discuss it. This is pure statistical things. So yes. So what is the relation between cumulants and CGF that you have, we have known these things, you know, right?
Yes.
So let me summarize. So if you have generating function that is fz, so then you will have the kth factorial moment, which is right. Second is our sorry, moment generating function. This gives you kth moment. Okay, and this is our CGF, cumulative generating function. So if you differentiate k times or r times, because here r is used generally because kappa and k looks very similar. So you see, this is not like just average or something. That's why this need a different notation. Kappa r. Okay.
Yes.
Now we can show that this cup u can be written as sum over r equals to 1 to infinity. All possible cumulants, if you add, and you have to add like u to the power r kappa r by r factorial. So it will be kappa u. Similarly, for our moment genetic function as well, you can write it was k equals to 1 to infinity u to the power k n k divided by k factorial. Whenever this relation is there for kth moment or kth rth cumulant, yeah, if you have to derivative rth prime or kth prime, then obviously if you have the reverse want to have the reverse relation, you have to sum over all possible r or k. This is just due to the Taylor series expansion. This is Taylor series, right? You see, when you this is ku. When you take the derivative for r prime, only r will survive and give you the kr kappa. That's due to okay.
Yes.
It is just Taylor series expansion. You see, and these are the component of the Taylor series, that particular rth coefficient. So this is the ultimate lesson. Okay. Okay, and what else? What else? Oh, okay, I'm not get to that. Later you will see there is a relation between. Okay, sure. Uh, it's not important. You don't know Fourier transform. That's why I'm not going with that. Do you know Fourier transform?
Little bit the formulas only.
These are PDF, right?
Yes.
If you want to do the Fourier transform, let's say I'm defining another p dash something m. So then it will be e to the power I n m of pn. Okay, kind of that. And if you remember now, mu, that was also kind of same. That's it. But so in general, mu is written like this. This is for real number when n is real, and this is general. This is for all cases, real and complex both. Okay. So that definition I written now
Okay.
for moment genetic function. This definition, this was the definition for moment genetic function. If you remember,
Yes.
that is for real number. Till now, whatever we have discussed, that is valid for real number only. If it is not real number, it may be complex number. Then I will be there for all cases. In case of CGF, in case all cases, there will be I. Instead of you have to use I. So whenever you have to change it from real to complex, later you will see, you, then you have to just replace u by I. Then it will be same. Nothing, everything will be same. Just you have to replace u by I. I is the imaginary number. Okay.
Okay.
And these both are called the moment generating function. This is moment generating function for real case and this is for complex case. Clear? But this is not called the characteristic function. I said this is characteristic function, general one, which one is valid for complex case as well. This is characteristic function. This is not. Okay. So for general definition, if you look into the books, you will see for all cases, instead of you, it is IU. Here it is IU. Every cases it is IU. Okay. Or you can see here it is I to the power R. Because if it is IU, I to the power R will be goes upwards and it will be minus I to the power R. That is for general cases, considering the complex number. So don't be confused. That is also true. Today we have discussed for the real cases only. For a complex case, in every instead of u, we have to consider it is I, not minus. Sorry, it is I. Clear?
Yes.
Okay. So let me stop here today. So I think this class was most difficult one, I guess, right?
Yes.
But this is so interesting, and this is if you just uh, write it once, and if you just think what was the roadmap, then it will be okay. Then it will be totally clear. Okay. So okay. Nothing left for today. Okay, so let me stop sharing first. If you have any doubt, you can ask. If both of you have any doubt, you can ask. Otherwise, so extra class, they say told you that I forgot to fill the form due to that puja vacation, but now probably they did not reply my mail whether I can take or not. So probably it is not happening.
Okay.
Okay, but it's okay. This part was also important, right? So are you giving the exam for this course, right?
Yes.
So when is this exam? It's online?
Yes.
Oh, 1st November. Okay. Okay, you have time, so you can revise it. And oh, I think the questions are will be bit difficult, but it's okay because I have seen ones beyond like this as question. Some questions are not straightforward, but most of the questions are straightforward questions. So don't worry, it will be okay. Or if you have any doubt in between regarding questions before this exam, you can ask me in WhatsApp. Okay, my WhatsApp number I have already shared in my lecture. Let me write it again here. Where I can write. So you can write it here, right? I'm not finding where it is. Okay, here. Okay, let me write it. You can ask me if you have any doubt. This is my WhatsApp number. Okay. So, okay, so if you don't have any doubt today, so you can stop here and we not meet again in next class. Okay.
Yes.
Thank you for joining this course. Okay, and best of luck for your upcoming exam.
Thank you.
Okay, thanks. Okay, goodbye. And I will upload this.